now that I think we have sort of assessed the first few, we have negotiated, we have understood the pitch and the conditions. Now let's see whether we can start the power play. So what I would like to ask the panelists would be, you have seen the aspirations of our department, and leadership and breakthroughs are words which are have been mentioned. So academia, you have an organization with smart people. Now, what would you look at the definition? How would you look at a definition of a breakthrough in industry? And what do you think is the definition of breakthrough in an academic department? How would you classify that so that we understand what is a breakthrough, and then we can set ourselves to achieve that or create a mechanism to achieve that? First, I'd like to ask Dr. Alok Nath.
See, in the current context, I think in the academia, what we see is methods and techniques. And in that, it's a bit more horizontally. For example, many institutes are specializing in AI, ML, or in data science, or in blockchain. So they take a topic, and there are techniques that are evolving, and then they keep on publishing, maybe some cases patenting. You are talking about following, but some cases even taking a leadership's role in publications. So that is an academia setup in that context, and it requires smart people, intelligent people, rigorous, dedicated people. What we do in industry is a little bit more vertical, because at the end for us, it's a business and it needs different skill sets. So for example, if I would like to take it that 5G or beyond 5G, as we are moving and we are talking about 6G, even 6G research has started in academia, but also in industry. I would like to take it like, for example, so far it has been on terrestrial network, but 6G, when it comes, there would be non-terrestrial networks, like it's becoming three-dimensional. You have the HAPS and drones and naval communications and other kinds of communications. It is not anymore terrestrial. So I would go differently and say, oh, I don't have that non-terrestrial part of it. And if I have to lead it, then I need to bring that. And therefore it becomes a little vertical from that angle. Let me take again a simple example. Nanoelectronics, many chipsets that people in the academia are doing research in the sensors, and these are elements. But what we do in industry then, we'll take it like a body communications. And I would like to see some maybe we are going to be building either in protocols or in sensors and certain communications, how we can do non-invasive, different kind of biological measurements or communications for that matter inside the camera's role into inside the body. So we take it from a little different angle and then do it. What is the difference is, at the end, these are the products. And if your goal is to take leadership, then that's the final delivery. I mean, obviously, so far, publications are also deliveries, so I have no dispute. But if you are wanting to make an impact on products, on solutions, then this is the path. And in that path, if industry and university could collaborate, and many of the topics that we are doing it, then it would be great. And I'll take one more example. In the ECE department context, and you talked about past, is it liability? It's still in my mind. A lot of antenna, electromagnetic theory, this is very old topics in some way, right? And ECE department is a repository of that. Even if I don't take computing part of it, and Professor Narahari talked about ECS view, and I agree with that, but I'm saying, forget about that as a separate topic. But even if I go back to this route that has been there, if I again go into future communications, the MIMO, the massive MIMO, the gigahertz to terahertz, all millimeter wave, this is actually antenna evolutions. It can rule the world. Therefore, I think it's a way of viewing, anchoring in the past and understanding what the future is going. Probably one thing that university needs to do, and particularly in IISc's case also, I would say that when we define it, if we can define as a program to start with, that these three things, select and focus. In industry, we talk about select and focus. Sometimes we have to kill something. It is very painful, but ruthlessly we have to kill because I don't have enough expertise or it's not moving in a big direction. So if we can say that, let's say non-terrestrial and body communications and antenna-based things, I'm just giving some examples. If these are topics that we would like to proliferate, then any hiring of faculties, any students must also be aligned, because all the metrics that we talk about, therefore our MBOs would be aligned to that goal. Otherwise, everybody starts to build their own labs and it may not add up to that breakthrough things, because every individual is great, but today I think most of the European countries, the country to country, there is a lot of synergy and cooperation. And if in the same institute we'll not be able to make a big cluster of topics, then it will be hard to make that impact. So my request would be to think big, small programs here and there, we may have to kill, relocate, and against those programs, we should do all of the things in terms of recruitment, research, emphasis, the government grants, all of the points. Thank you.
Thank you, Vallabh. So I'd like to request maybe or seek Professor Narari's comments or response to what we have heard as an industry view about what the department should be doing and how ISC can respond towards achieving that.
Thank you, Hari. I completely agree with Aloknath on the viewpoint he's taking regarding how we should engage with the industry. I feel that breakthroughs will come if we are willing to take a risk, and there are many different ways in which one can take a risk. Just about 1.5 years back, we were all struck by the COVID-19 virus. And there was an opportunity which I think ECE department really grabbed. I know the sleepless nights that Gaurav Banerjee spent, and I know the stellar efforts of Rajesh Sundaresh, Himanshu Tyagi, Aditya Gopalan, Naveen Kashyap, and many others. It's possible that I have forgotten several other people. And so when the opportunity, came knocking, I think people got out of their comfort zones and something really nice emerged. I think there lies, the mantra. I think we have to come out of comfort zone. Many of us faculty members, have this tendency of getting into a comfort zone because we're very comfortable doing more of the same thing. So I think that mindset will have to go away. If that has to go away, then we should be looking at really engaging problems. For example, we should be looking at India-centric problems. We should be looking at industry-centric problems. I'm sure if a team of faculty members goes and spends 1 full week with Aloknath, he will tell us all the intellectually challenging problems that the faculty members could be working on. Similarly, I think if we can spend some time with the DRDO scientists and ISRO scientists, there is no reason why an India-centric problem cannot emerge. So I feel that we should get out this comfort zone and engage with our national agencies, engage with the industry in a much more intense way, and that will be the source of the kind of problems that we should be solving. once we are able to get hold of the really interesting problems, the really engaging problems, rest of the journey I think can be planned. There have to be some champions among the faculty members to drive the show. And as I said, if you want to find a complete end-to-end solution to any problem, it will require a collaborative effort, not only within the ECE department, but you'll have to collaborate with other people in other departments and so on. And also, I completely agree with Himanshu that systems engineering has to be given a lot of importance. Unless we build systems, unless we dirty our hands and actually build the devices and the systems, I don't think we will be able to see the end of the solution. If we really want to hit the solution, systems engineering is going to be extremely important. That is what AI/ML also has shown. AI/ML without data engineering is not able to deliver any solutions. So I think that's going to be very important.
Thank you, Prasanna Hari. Few years back, I had a good fortune of meeting Dr. Vishnu Atal, who was a distinguished alumnus of ECE, IAC, and worked with Bell Labs. So I'd like now to, and when we posed a question, myself and a few of our colleagues were there at a conference talking to him, and we asked him, what made Bell Labs tick? And what do you think we should do in IAC and ECE department? Because he was very fond of his department. So he said, put bright people into the institute or the department, give them the freedom to do what they want to do with a goal or a focus which is relevant to what the society wants. So that was a very striking, in fact, that maybe was the policy of trying to recruit the best. So I would like to now ask Anurag, since he also worked at Bell Labs, what is it that is missing? Or what is it that we should be doing? Because we do have bright people on campus. And what is it that we can light a fuse to create the technology earthquake we need to? Anurag?
Okay, thanks, Hari. Can I share a couple of slides?
Yeah, sure.
Okay.
Are you able to do that?
Yeah, I think I can, yeah. So I think the Bell Labs aspect will come across in the next slide. In this slide, I would like to address an important issue which sort of follows up on what Hari and Hari also mentioned, that we are hiring the best and yet we don't seem to be able to see the kind of breakthroughs that in fact was seen from Indian people like Raman and SN Bose and JC Bose, decades back. So I think I would like to analyze that a little bit and present this few points to the many people gathered here. They are very provocative, but I have presented them to the highest levels in our country, so nothing to be embarrassed about. So an important thing to note, whether it's industry or government or academia, that people shape their working styles to conform to evaluation criteria. But evaluation criteria in Indian academia in the recent years, it wasn't perhaps the case in Raman's and SN Bose's time, are heavily geared towards just counts, publication counts, PhD student counts, awards and fellowship counts, and the counting just goes on. And individual contributions. So when we evaluate people, often it is asked, who is the first author? Who led the group of these people who authored this paper? And although these are important questions, often the conclusion of the evaluation stops at looking at these questions. Who led the work and who was the group leader? And in fact, these criteria pervade the selection process for academic fellowships, awards, and recognitions, which unfortunately have become very important for our faculty in India. If you just count the number of fellowships and awards and the promotions that any assistant professor would want to aim for, there are about 12 of them. You can probably count a bit more. So in a 30-year career, this young person is aiming for a new milestone every 2 or 3 years, whereas they should be thinking long term, thinking about those breakthroughs that we all seem to crave for. So what happens is that faculty simply work towards piling up the counts, often not trying something new and risky, and this is a very important point, it might interrupt the flow. If you approach a faculty member saying, would you want to be involved in this project? It's exciting. It'll take away some of your time. It's risky. No, it'll interrupt my flow, which will prevent me from seeking the next goal among the 12 that I'm aiming for. The objective seems to be to set a high rate of publication success. That's the key word here, high rate of publication success, not high rate of impact on the field or on a certain problem. So just your throughput in publication in good journals and conferences, which is actually a laudable goal, but perhaps it's a bit dated now in today's context. We also avoid setting up collaborations in an increasingly interdisciplinary world. And Natali already pointed out, we should think EECS rather than only ECE, and we should collaborate more. Why do people tend to avoid collaborations? Because collaborations take effort. You have to travel to meet other people. You have to manage cultural differences. Imagine a collaboration between somebody in Korea, India, and France. Cultural differences are involved, which are very important to sort out. But the collaborations pay off hugely in getting good problems, problem diversity, expertise diversity. You don't know everything yourself. In networking, in getting your department and yourself and your institute known outside the four walls of the institute, and visibility. So somehow we need to be able to assess people, not by the criteria I have outlined here, which are the criteria which we always use in our country, and perhaps in our institute and other institutions. But it's not easy to do. It is not very easy to assess impact rather than volume. So we always sort of gravitate towards the easy thing to do and just assess volume. We need to look at best practices around the world. How is it that in other countries, particularly in the US, they're able to evaluate people in a way that gets the best out of them? We started something like that a few years back, where we want to assess only 5 papers rather than 200 papers somebody may have. My second point is about what Himanshu and also Aloknath mentioned about impact on systems, impact beyond just the discovery impact. So this is actually something which comes out of Bell Labs. Narayan Murthy was a well-known researcher in Bell Labs. He then went on to establish the Harvard School of Engineering. Before he was second dean of material science in Santa Barbara. And this is we often think in academia that, look, we are interested in discovery. We are interested in fundamental questions. So why should we worry about the invention process? But in fact, what Bell Labs showed, and in fact, not only Bell Labs, industry has showed, is that the invention and discovery are closely linked. Okay, you had top minds in Bell Labs who are involved essentially in delivering services to the public. But every invention raises fundamental questions which lead to discovery research, which people would do. And then that research would then lead to getting the invention possible.
Anurag, the slide has not moved. The slide has not moved.
I'm sorry, what happened? What happened?
I'm still seeing the old one, the researcher evaluation slide.
Okay,
have you moved to the next slide? Yeah.
Yeah. Okay, I'll go. Okay, you missed this picture.
Yes. Yeah.
Visible now. So I was talking about this discovery invention cycle. I mentioned that in Bell Labs, which you mentioned I should speak about, there was this desire to provide services and products to the people. And how would people do discovery research in that environment? And a lot of it happened out there. There were Nobel Prizes there. Well, invention raises fundamental questions, which require discovery research, Nobel Prizes, and which then lead to solutions, which then are plowed into inventions, and cycle goes on. But nowadays they talk about the discovery invention network. That's the new thing that I've been reading about rather than only a cycle. So here are examples. Some people say that the Second World War was won because of microwave radar. It was developed in MIT. Microwave tube was imported, was brought from UK, and then they did research in radar in MIT. The polio vaccine, the science came out of the Harvard Nobel Prize. The SPICE simulator, which came out of a PhD thesis in UC Berkeley, it changed the way people do electronics about 20 years back. Of course, IBM's QA technology, which probably started the ML AI revolution, and so many others. And what we lack in India, which Alok Nath Dey has talked about, is this government, industry, research universities triangle, which in our country is completely broken. None of these edges really work. Government gives money to the research universities, they give nothing back, except of course manpower. Government industry doesn't even support the industry. And there's a lot of suspicion between research universities and the industry. So I think you can read this quote I picked up from somewhere, that the Chinese Science Ministry announced last quarter, the nation's first ever open AI platform rely on Baidu and Tencent and Alibaba. So there's so much trust in these companies, which probably has changed the AI landscape in China. We need to strengthen this government, industry, and academia research triangle. Thank you. That's all I have to say.